Okay, in this video we're going to take a look at evaluating functions using function notation. And we typically use function notation such as f of x or g of x when we write functions rather than using y. In the last video we saw when writing the rule for, or writing a function given the rule, we used f of x and g of x. Really, the function names themselves, f and g, we can use whatever letters we want. In fact, we can even write out words. So, for instance, if we have an area function that calculates area, we could use the letter A, or we could even write out the word area. Just in math, we tend to not want to write out a lot of words. And as far as x is concerned, we can use any variable we want. It's just traditionally we use x. So, but bear in mind, we could do f of A or g of w or f of happy face for all that matter. So to evaluate a function, all we have to do is substitute the value in parentheses into the function itself. So in prior math classes, you would have been told to evaluate an expression for a value of x. Here, it's the same thing. We're just going to use this function notation. So example 4, we have f of x is negative x squared plus 3x plus 4. We're going to evaluate f of negative 1. And when we do that, we're going to plug negative 1 in for x into our function. So we have negative and then negative 1 in parentheses with the exponent outside the parentheses, plus 3 times negative 1 plus 4. And that'll give us negative 1 minus 3 plus 4, which is equal to 0. Now there is a video on the Desmos playlist on how to use Desmos to evaluate functions, and I highly recommend you use that for evaluating functions at a value. Part B, we're going to evaluate f of 0. So we plug a 0 in, we get negative 0 squared plus 3 times 0 plus 4. That gives us 0 plus 0 plus 4, which is 4. So plug in a 0, we get back a 4. F of 2, we have negative 2 squared plus 3 times 2 plus 4. So negative 2 squared is negative 4 plus 6 plus 4 should give us 6. We can even, in part D, we can plug in expressions, not just numbers, but expressions into a function. And we're going to get into more depth on what this actually means later on in a future video. But for right now, whatever's inside parentheses, we're just going to plug it in to the function and see what we get. So this time we have negative 2x in parentheses being squared plus 3 times 2x plus 4. Now, unfortunately, when we have a variable that we're plugging into our function, we can't use things like Desmos to help us with that, so we're going to have to do a little bit of algebra here. So first up, this negative 2x in parentheses squared, your order of operations say to square the 2x before you make it negative. So squaring 2x is 2x times 2x, which is 4x squared, and then we'll make it negative. So we have negative 4x squared, and then plus 3 times 2x is 6x, and plus 4. And there's no like terms to combine, so our final answer is negative 4x squared plus 6x plus 4. All right, finally part E, f of x plus 2. So this time we're going to plug in an x plus 2 into our functions. We have negative in parentheses x plus 2, and then the squared's outside the parentheses, plus 3 times x plus 2 plus 4. So again, all this function does is it takes whatever you give it, it squares it, takes the opposite of that, adds it to 3 times what you gave it, and then add 4 to that and give you back a final answer. So with the exponent for x plus 2 in parentheses squared, that's x plus 2 times x plus 2, which is x squared plus 4x plus 4. And we can even distribute the 3 to the x plus 2. We'll get 3x plus 6, and then bring down this 4. So we have a negative outside these parentheses here. Now we can distribute this negative to the x squared, the 4x, and the 4. And we get negative x squared minus 4x minus 4. So again, negatives just make them the opposite. And then bring down the plus 3x, the plus 6, and the plus 4. Now when we combine all of our like terms, we get negative x squared, negative 4x plus 3x is negative x, and then negative 4 plus 6 plus 4 is 6. So we can even plug in other expressions to functions, not just numbers. All right, that about does it for this video. Thank you for watching, and I'll see you next time.